Welcome back, all my aspiring mathematicians. Today I'm going to dive into the topic of how to rationalize denominators. Rule number one when it comes to math, you cannot have a radical expression in the denominator of your answer. If you are given a fraction in math and you have the denominator as a radical, you have to rationalize that denominator so that your answer will not have a radical symbol in the denominator. And how do we do this? So let's first define what rationalizing denominator is. Rationalizing denominator is the process of moving a radical expression such as a square root or a cube root from the bottom of the fraction, which is the denominator, to the top of the fraction, which is the numerator. And we have to do it because you cannot leave your answer with a radical expression in the denominator. And even if the problem is given to you that way, you have to rationalize it. And in certain concept in math, you will notice that you will have that situation occur and you will need to know what to do. So let's show you how to rationalize a denominator in this topic today. The key thing that you need to remember is that you have to multiply the original fraction that is given to you by a radical expression which is equivalent to 1, meaning whatever it is, if it is a radical 2 you have at the bottom, you have to multiply it by radical 2 over radical 2 so that that radical 2 over radical 2 is equivalent to 1. You're not changing anything. And when you do that, then you will be able to rationalize the denominator, the both radicals there, which is a radical 2 times radical 2, which you will now end up with 2 in your denominator as your answer. So let's get into a first example on how to rationalize a denominator. Example number 1, if you're given 4 over radical 3 and you're asked to simplify this, because you have a radical 3 in the denominator, and the first rule in math is that you cannot have a radical in the denominator for your final answer, and to simplify this or get rid of it, we are going to rationalize it by multiplying by radical 3 over radical 3. This is going to be equivalent to 1. So note that we're not changing anything. It's simply saying the same thing as if we are multiplying radical 3 times 1. That 1 is equivalent to radical 3 over 3. And we're using what we have here in the denominator. So once we have this, the next thing we will notice is that when we multiply across, this is going to give you 4 radical 3, and you multiply what's at the bottom, you are going to get radical 3 to the second power, or you can have radical 3 times radical 3. It's going to be the same thing. One of the rules when you are dealing with radical, which is a square root here, the index would be 2, which is an invisible 2, and you have raising it to the exponent of 2, those two are going to be cancelled out. So you will end up with 4 radical 3 over 3. And this is your final answer. Okay? Now, if you didn't do it that way and you gave me or 4 radical 3 over radical 3 times radical 3, we will notice that we'll have 4 radical 3 over radical 3 times radical 3 is radical 9. And so our final answer here would be 4 radical 3 over square root of 9 is 3. So that's another way that you could have done it. You still arrive at the same answer. The next example I'm going to give you is that you're going to simplify the square root of 1 over 5. So there are rules to this, and you can go back and watch my video on multiply and divide the radicals, and I talked about when you have a fraction underneath the radical, what you have to do, and we are going to do it now. So we are going to change that, and we are now going to break it up into radical 1 over radical 5. We still have a radical 5 in the denominator, so we have to rationalize that. When we rationalize that, we are going to end up multiplying it by radical 5 over radical 5. All right? Now we're going to go multiplying across Radical 1 times radical 1 is simply going to be radical 5. And we can simply do this as radical 5 times radical 5 is going to be radical 25. And we're going to get radical 5 over square root of 25 is going to be 5. And that is what you get. And obviously, you can do it this way if you didn't do it like this. And you will end up with radical 5 coming from here over radical 5 times radical 5. What you now have to do is simply, you're going to have here radical 5, because square root of this, you can write it as square root of 5 to the second power. You know this is going to cancel that out, and you will now end up with answer as radical 5 over 5 as your answer. And that's what you get. Now, this all has to do with square root, because the index here would be that invisible 2. But guess what? I'm here to show you also what would happen if you have to take the cube root. So if you have to take the cube root, there are steps that you're going to take, and I'm going to show it to you right now. So what if you're asked to simplify, and that's 1 over cube root of 7. Notice here the index is 3, and because the index is 3, you have to treat it accordingly. One of the rules that you should remember, just like finding the square root, if you have the square root of 2 raised to the second power is going to give you simply 2, because that is going to cancel out that. The same thing here, the cube root of any number, whether it is say 3, raised to the exponent 3 is going to cancel out, and that's going to give you 3. So that's one of the rules that you must adhere to when you are dealing with radicals. So let's continue with our problem that was given to you. So what you're going to do now, you have 1 over the cube root, and let's write that so it's visible. It's a cube root of 7. So make sure it is in here and you're not writing it as 1 over 3 radical 7. No, this is wrong. It's 1 over index is 3 and the 7 is here. Index 3, 7 is there. Okay? So because we're dealing with the cube here of 7, we have to multiply this when we are rationalizing the denominator. And we have to multiply this now, not simply as the cube root of 7, but we must raise it to the second power. All right? And the reason why you are raising it to the second power is because the index is 3. You need to get a 3 underneath, 3 sevens underneath the bottom, or 3 of whatever number or variable you have there. So that's the reason. If you were doing it with just the square root symbol, you multiply by the square root symbol. That is going to help you to get the second power, which is cancelled out. But the whole thing is that you need this to be raised to the third power. And the only way you can do that is to multiply whatever you have with it raising to the second power here. Because this is now, when you're multiplying across, you're going to get the cube root of 7 raised to the second power, right, over the cube root of 7 here. But when you're multiplying the exponents, this will be an invisible 1. It is now going to be 1 plus 2, which is 3. Okay? So this is what it's going to look like. Now, because it looks like this, then you simply will notice you can rewrite it. And I'm going to rewrite it again because I want you to see clearly. I don't want to mess up what I'm writing. So I'm rewriting that, and I'm doing it with the index of 3 raised to the third power here. So from this, you will notice that you need to get rid of that, right? And now you can go ahead and say you have the cube root of 7 to the second power, which is going to be 49. And let's get rid of it, make sure that that looks like a hook. And that is going to be over 7. And this is going to be your final answer. You can't do anything to this. So the main idea here is that if you are dealing with cube root, be careful with what you are using as your fraction to rationalize the denominator. It must be raised to the third power in the end. And in order to do that, this would be an invisible one power that you have, but you don't write it, but I just put it there, make it look invisible. And you must have a second power here. If you don't do that, you're going to get into problem, because, let me show you. If you did that, you're going to end up with, if you had cube root of 7 times cube root of 7, this is simply going to give you cube root of 7 to the second power. You cannot cancel anything out here. So that's the reason why you need to end up with the third power here, so you can cancel out the cube root, right? The index here with this radical symbol and the exponent 3 to end up with just the number that's underneath, which is the radicand. That's why that is your answer. So be very careful there. All right. As you know, this is not going to be all I'm going to show you. I need to show you something else. So let's get into our next example dealing with rationalizing denominator. So our next example is that we are going to simplify radical x to the 5th power over 3. And when we have it like this, we still have to break this apart, and we are going to have it as radical x to the 5th power over radical 3. I'm going to rewrite it here, right? And then I'm going to rationalize the denominator, because I'm going to show you what is going to happen. And I'm taking radical 3 over radical 3. So this is going to give me radical 3 times x to the 3rd power. One thing you can do with this, you can do it in one of two ways. You can literally break it up. You can have radical 3, I always put the number first, and then times it. I'm going to break up the radical 5 into either two sets of like this, radical x to the 2nd power, and then radical x. So this is that 5 that we have over radical 3 to the 2nd power. So this is going to give me radical 3. This is going to cancel out, which you have the exponent there is going to cancel out. So you will have x times x and radical x over, this is going to be just simply 3. All right, so this now is going to be radical 3x, I'm multiplying these two, times x to the 2nd power over 3. So your final answer here is going to be, you put your non-radical first, so x to the 2nd power radical 3x over 3, and this is your answer. But if you did not do it like this, and say for instance, if you did it where you went, when you broke it up, you could have chosen another way. Or if I can rewrite this that I have, which is radical 3 times radical x to the 2nd power, or 4, write it like that, times radical x. So you could have written it like that. If you chose to write it like that, then you could also have square root of 9 there. And this now is going to cancel that out. You will end up with x squared, put the x squared first, square root of 3x over 3. And you notice that you get your same answer here. So it's your choice. You broke it up, or you could have said 4 first, and then the 4 you break down. So even if you didn't jump to this line, you could have started with radical 3 x to the fourth, which is a radical of that, times radical x, and then get into this. I have one last example that I want to show you. And this example is the fact that you don't have a number as the radicand, you have a variable. Yes, you know me, variety is the spice of life, so I'm going to show it to you and show you what to do. So our next example is 3x over radical x. And you're asked to simplify that. We are going to rationalize the denominator with the square root of x over square root of x. And that is going to give me 3x radical x over radical x to the second power, right? And this is going to give me 3x radical x over x right there. And because you have that x right there and you have 1 above, you can simply look at those and you just cancel out that x. So your answer now is going to be 3 radical x as your answer. And you don't put over 1, you just leave it as that. So that is your answer for that. If you are given another example which is almost like this, and you're given 3 over radical x to the third power, you don't have to rationalize the denominator with multiplying it by radical x to the third power. You can do so simply by rationalize it with multiplying it by the square root of x over the square root of x. And you cross multiply here, that is going to give you 3 radical x. And for the bottom, you're going to get radical x to the fourth power. Now, because you have radical x to the fourth power, what you can do now, you can break it down. So you have 3 radical x over radical x second power raised to the second power. You will note that that is literally going to be 3 radical x over x to the second power. And because you have this here, this is going to be your final answer for this type of problem. There is nothing else that you can do here. So in conclusion, now that you know how to rationalize denominators working with square root and also with cube root, I hope that you will adhere to all these steps and you will be successful on the next math problem that you have to deal with rationalizing denominators. The rule in math is that you cannot have a radical expression in the denominator for your answer. So you have to simplify it by rationalizing the denominator to get rid of that radical expression. So I hope that you will abide by the rules and don't make any mistake and give the correct answer when you are doing math that has fractions that deal with radical expressions. With that being said, if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit the like button if you like what you see. And don't keep this to yourself. Share it with others around the world so they too can learn how to solve math like this and other type of math problems. I also have other videos on fashion and finance. Go ahead and watch those videos. Thank you for your support and see you soon on the next video to come. Bye now. Cheers.